It rains solid diamonds on other worlds. Right now, thousands of kilometers above two planets in our own solar system, something extraordinary is happening. In skies of crushing pressure and freezing storm, solid diamonds are forming out of the air itself and falling like rain. Not a handful of stones, but a ceaseless downpour of glittering gems drifting slowly toward the hidden cores of distant worlds. It sounds like a fairy tale, yet the physics behind it is real, and scientists have now recreated diamond rain in a laboratory on Earth. To understand how a sky can rain diamonds, we first have to understand the strangest, hardest, most misunderstood stone we know. A diamond feels like something rare and magical, forged purely for beauty, but at heart it is astonishingly ordinary. It is made of a single element, carbon, the same stuff as the soot in a chimney and the graphite in your pencil. The only difference between a worthless smudge of pencil lead and a priceless gem is how the atoms are arranged. In graphite, carbon atoms lie in loose sheets that slide easily apart, which is exactly why they leave a mark on paper. In diamond, every atom is locked to four others in a rigid, three-dimensional cage, one of the tightest structures in all of nature. That cage is what makes diamond the hardest natural material on Earth. Nothing else can scratch it, yet it can scratch everything. It also carries heat better than almost any metal, while barely letting electricity pass through it at all. And it bends light so sharply that a well-cut stone seems to catch fire from within, throwing sparks of color in every direction. But this perfect prison of carbon cannot be built by any gentle means. To force carbon into a diamond, nature needs heat, time, and a pressure almost beyond imagining. That pressure is not found on the surface of our world. It lies far beneath our feet. Most natural diamonds were born more than 150 kilometers down, deep inside the Earth's mantle. Down there, the rock is hot enough to glow, squeezed under the crushing weight of the entire crust above. In that furnace, over hundreds of millions of years, lone carbon atoms are slowly pressed into flawless crystal. But a diamond born that deep should have stayed there forever, locked away beyond any hope of reading. So how do these stones ever arrive at the surface, into a miner's hand or onto a wedding ring? The answer is one of the most violent kinds of eruption our planet has ever produced. Long ago, rare and colossal blasts tore straight upward from the deep mantle toward the sky. They raced up through the rock at tremendous speed, punching narrow pipes all the way to the surface. These eruptions were so fast that the diamonds had no time to turn back into ordinary carbon along the way. The rock they left behind, called kimberlite, forms the deep pipes where nearly all mined diamonds are found today. Every diamond in every shop is a passenger from one of these ancient elevators out of the deep. And these passengers are old, almost unimaginably old. Most diamonds formed between 1 and 3 billion years ago, when the Earth itself was still young. That means the stone in a ring may be older than every animal that has ever lived. Older than the dinosaurs, older than fish, older than the first leaf and the first breath of oxygen, rich air. When these crystals formed, life on Earth was little more than a film of microbes drifting in a lifeless sea. Trapped inside some diamonds are tiny bubbles of ancient minerals, sealed samples of a world we could never otherwise visit. To geologists, these flaws are not defects, but time capsules from the deep and distant past. There is even a strange truth hidden inside that famous phrase, "A diamond is forever." At the surface, diamond is not truly stable. Given enough time, it will slowly turn back into humble graphite. It is simply so slow that we will never see it. Now we can return to those alien skies and to the rain of gems falling through them. Far from the sun lie two giant worlds of ice and gas, Neptune and Uranus. Beneath their calm blue faces, the pressure climbs to millions of times what we feel at sea level. Their deep atmospheres are rich in methane, a simple molecule of carbon and hydrogen. As methane is dragged downward, that crushing pressure and heat rip the molecules apart, setting the carbon free. Squeezed hard enough, the freed carbon locks into the very same rigid cage we call diamond. And so, deep inside these planets, diamonds are thought to crystallize and sink slowly toward the core, like a strange, sparkling snow. For years, this was only a beautiful theory, until scientists decided to put it to the test. In a laboratory, they fired one of the world's most powerful lasers at a slice of ordinary plastic, itself made of carbon and hydrogen. For a split second, the shock recreated the pressures found deep inside an ice giant. And in that instant, in the flash of the blast, tiny diamonds appeared out of the plastic, diamond rain made on Earth. It confirmed that on Neptune and Uranus, the sky really can turn carbon into a downpour of gems. The cosmos, it turns out, is far richer in diamonds than any king who ever lived. When certain dying stars collapse into white dwarfs, their carbon-rich cores can slowly crystallize over billions of years. Astronomers have found such a star whose heart may be, in effect, a diamond nearly the size of a planet. Back on Earth, we no longer have to wait for the deep mantle to make our gems for us. In modern laboratories, engineers now grow real diamonds in a matter of weeks, atom by atom, from little more than heat and carbon gas. These lab-grown stones are not imitations. They are chemically and physically true diamonds, identical to the ones from the deep. And diamonds have quietly slipped far beyond jewelry into the tools of modern life. Their unmatched hardness sharpens the blades and drills that cut through stone, steel, and glass. Their tiniest flaws are being turned into ultra-sensitive quantum sensors and may one day sit at the heart of new kinds of computing. So the next time you see a diamond flash in the light, remember what you are really looking at. A knot of ancient carbon forged in a hidden furnace, older than the dinosaurs, and a cousin of the gems that fall as rain on distant worlds. Follow Worth Knowing for more things worth knowing.